Welcome back, Prep Station Physics, UTME 2025. Okay, so we want to quickly look at types of force before we continue. Force is a physical cause. Yeah, it's a physical cause that can change an object's state of motion. I explained that before. So the only reason why objects move or stop is the application of force. There are two types of forces based on the application. Like I said before, you may see more than this on net, but we have just two based on the mode of application. Number one is called contact force. Now, contact force has to do with touch. There must be a touch with the object of application. So there must be what? Contact or touch. You must touch the object. There must be a touch between the source of the force as well as the object that the force is being applied to. Then number two is called non-contact force. So in number two, there is no touch between the object and the source applying the force. Okay, so examples of contact force. These include muscular force, mechanical force, and frictional force. Yeah, of course. Muscular force from our body, and then mechanical force from kinetic and potential forces. And then you have the frictional force. Of course, frictional force will not happen if the two conditions for friction are not achieved, which of course is the two objects must be in contact, and then the two objects must be in motion. For example, if I rub my palm, okay, after some minutes, I'm going to generate heat. That is friction. But if I keep these two palms away from each other and then I continue to move it this way, friction can never occur. So these three are examples of contact force. There must be a contact, okay? Then let's move forward. Examples of contact force, non-contact force, we have gravitational force. Of course, if you are on planet Earth, which of course I believe you are acted upon by what? Gravitational force. It is the force responsible for every object on planet Earth to do what? To come down. Then you have the electrostatic force. Forces due to what? Charged bodies. This is called electrostatic force. Forces due to charged bodies. And then you have the magnetic force. Everyone knows about this, magnetic force. Of course, the force that when a substance attracts other metallic material to itself, you have magnetic force. Now let's go to the linear motion proper. Now, remember there are other types of motion, but here we are just looking at linear motion, okay? If you can handle linear motion, you can handle every other type of motion, including projectile motion, because it is the same basic equations of motion that is being used for other types of motion. Now, it is the motion of an object on a straight line. That is the meaning of linear. Is the motion of an object on what? On a straight line. The parameters for defining linear motion are speed, velocity, and acceleration. These are the three parameters for defining linear motion: speed, velocity, and acceleration. Now, these parameters can be combined to derive the equations of motion below. So let's quickly look at the equations of motion. The four equations of motion. All right? So we have equation number one. Motion under constant acceleration can be described using the following four equations. Let me quickly show you how these equations are derived. I like doing this because sometimes the fear of students in studying physics is the fear of equation. Okay? So this is equation one, and this is actually derived from the definition of acceleration. Acceleration. Now, what is acceleration? Increase in speed, increase in velocity. Okay, so acceleration A is defined as change in velocity over time. Now, to have change in velocity, that means there must be two velocities in place. Final velocity and initial velocity over t. So you have A is equal to V2 minus V1 over what? T. If you make V2 the subject of the formula, although this is represented in Nigeria curriculum pattern, so let me use that here. So A is equal to V minus U over T. V for final velocity, U for initial velocity. So if you make V the subject of the formula by cross multiplying, then you are going to get equation 1. So let me call this equation 1. Now, the second equation of motion is S is equal to UT plus half AT squared. And then the third is V squared is equal to U squared plus 2AS. And then the last one. We can use this last one to derive these two by substituting equation 1 into this. It's very simple. Let me show you how to do that. Now let's call this, this is equation 1. This is equation 1. So let's call this equation 2. Because this is actually equation 2. And then this is 3. This is 4. So how do you derive equation 2? From 1 and 2. It's very simple. All I need to do is to substitute. Follow me. Just substitute equation 1. This into equation 2. For what? For V. For V. Substitute equation 1 into equation 2 for V. So let's go. S stands for distance. So you have half into bracket U plus. So where I have V, I'm not going to write V. Instead, I'm going to write U plus AT. So U plus AT, bracket close, and then you have the time. So if you open up this bracket, you are going to get U squared, 2U, you are going to get 2U, let me see if I can quickly remove this. All right. So you are going to get U plus U, that will be 2U T, and then plus AT squared. AT squared. Don't forget there was half. Now, if I continue to play with this, then I have S equal to 2UT over 2 plus AT squared over 2. Now, if you rearrange this, what happened? 2 will cancel 2 here. So I'm left with what? S is equal to UT plus half, then AT squared. Now look at this equation and look at this. So that is how you derive equation 2. By substituting equation 1 into equation 4. Let me quickly do the last one. So for the last one, the same pattern. But this time around, I'm going to substitute equation 1 into 4 for t. I'm substituting equation 1 into equation 4 for what? For t. So that means I have to go back to equation 1 and make t the subject of the formula. So let's do it together. So here you have V is equal to U plus AT. So if you make T the subject of the formula, then you have T equals to V minus U over A. So substitute this into equation 4 to get equation 3. Very simple. Let's do it together. So here we have S equals to half into U plus V. Now, where I have T, I'm not going to write T. I'll simply write what? V minus U over A. So V minus U over A, bracket open and close. Simply play with this using your knowledge of mathematics, algebraic expansion. So if you do that, then you have half into, by the time you multiply this, you are going to get U squared plus UV minus UV, and then minus v squared. Yep, let's see that again. U plus v into this. So you get u squared plus uv minus uv, then minus v squared. So we continue. So this will be equal to plus uv minus uv will cancel each other out. So I am left with what? U squared minus v squared over 2a. There was a. Okay? Now, if you continue, what do you do at this point? Cross multiply. So you have 2as will be equal to v squared, all right, u squared minus v squared. Of course, if you make v squared the subject of the formula, then that will give you v squared equals to u squared plus 2as. Now look at this equation and look at this, u squared plus 2as. So that is how you derive equation 4. Very simple. Now, why I dwell so much on this, if you know how to use this 4 equation, you'll be able to solve problems related to motion in physics, whether projectile motion, two-dimensional motion, or whatever. All you need to do is to modify the formula. So let's move forward. Now that we know the formula. These are known as the constant acceleration equations, where u is the initial velocity, a is the acceleration, and s and v are what? Displacement and velocity, and time is t. All right. Good. So let's attempt some questions, okay? Just to be sure that we have learned something, okay? Question 1. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters in 10 seconds. What is the acceleration of the car? Okay, let me do this. Okay, it will be possible. I wanted to write the 4 equations of motion to see how to make choice. How do we choose from the 4? Now, how to determine which equation to use is to look at the parameters given in the question. So we're going to look at these parameters and then find out. A car moves with an initial velocity. So start with that. U is equal to 25 meters per second, okay? And reaches a velocity. So this should be final velocity 45 meters per second in 10 seconds. So the time t is 10 seconds. What is the acceleration? We are looking for a. So you put question mark here. Now look at the parameter u, v, t, and a. Which of the equation of motion will handle this problem? For me, as a physicist, I can use any of the equation, but I will always advise my students, go for the equation that, consists of the parameters in the given question. So equation number 1 can handle this. How do I know? Because equation number 1 simply says v is equal to u plus at. This is the first equation of motion. So look at it. We have u, we have v, we have t, we have a. So we can use this one. So all I need to do, come back here and make a the subject of the formula. Okay? Make a the subject of the formula. So a will be equals to v minus u over t. Right? So the next thing is what? Substitute these values into the formula to solve. So we continue. A equals to, what is v? V is 45 minus u is what? 25. Okay? Then divided by, what is t? T is 10. Therefore, a will be equal to 45 minus 25 is what? 45 minus 25. That should be 15, I guess. Yep, 15. Did I miss anything? 25, 45. 45 minus 25, that should be 20. Sorry, that should be 20. That should be 20. Okay? Then over what? 10. The time is 10. Therefore, acceleration will be equals to what? 20 divided by 10 is 2 meters per second square. Why did I put that? The unit for acceleration is meters per second. squared. Okay, let's confirm if that is correct. Yes, that is correct. 2 meters per second. So thank you so much. Let's go for a break. I'll be right back.